Hi there, this is Chantel, and I'm going to work an example problem very similar to the regression worksheet that you have in your statistics homework this week. It's a different problem, but with very similar questions. So we're going to be using Desmos to do some regression analysis, and instead of Excel, because I wasn't sure if everybody could get Excel, and Desmos is pretty nifty. Then I'm also going to show you how to do some things in Word. You may have a different version of Word. I have the iOS version for Mac. So if you have a different version and it looks different and you can't figure it out, I would pause the video and go look for a different video on YouTube to show you how to do that particular thing so you don't get confused. Okay, so the first thing we're going to do is we need to get this data into Desmos. But first, let's look at the question and see what it is that we're supposed to be doing. So the data on the average sea temperature, sea surface temperature, and coral reef growth is shown in the table. The first question is, which is the explanatory variable, the x-axis? That's the independent variable when we're in algebra. So we're looking at temperature and coral growth. So which depends on which? Well, coral growth depends on temperature. So temperature is going to be on the x-axis. So think about that first before you set things up. The x-axis isn't always given in the first column. Desmos and Excel both will assume that the first column is the x-axis. So this one is already set up for us. Don't assume it though. All right, so we're supposed to make a scatter plot of coral reef growth versus the average sea surface temperature. So what I just did was I just highlighted just the data, not the heading. And now I'm just going to copy. So Command-C or Control-C, however it works on your computer. And then I'm going to go into a Desmos file. So just open a new file, make sure you've signed in. So if you look over here, you can see that I'm signed in because my name is showing. It's also a good idea to go ahead and create a title for your graph so that it saves it. So I'm going to say Regression Example and save that. Okay, so let's come into the box. We've already copied our data, and this is a really nifty thing that Desmos does, is if you just say paste, and so I'm just going to say Command V, look at that. It just puts the whole table there for us, and it graphs each point. So now that's all done for us. Another thing in the question that it said to do is label our axes, so always get used to doing that. So you're going to come over here to the graph settings, the little wrench, and we're going to come down to the x-axis and add a label. So that is going to be, the x-axis was the temperature, so temperature was in Celsius, and y-axis is coral growth, so I'm just going to say coral growth, and that is in millimeters if I recall. Okay, so now we're just going to click out of there, and now at the bottom it should have temperature, and over on the side it should have coral growth. Okay, so the other question here is we're supposed to make a scatter plot, and don't forget to label the axes, describe the pattern. Are there any outliers? So, and we're supposed to insert the graph. So I'm going to go ahead and insert the graph and get that done so I can talk about it right here in front of me. There's a couple different ways to do this. One way is to click on Share Graph. Okay, so we're going to share the graph and we're going to export image. So instead of copying the link or printing or embedding, we just export the image. So if you've done this correctly, it should show the axes labels here. So they're both there, and it should have all the numbers there. I usually just do medium square. You can change your line thickness, but that's more for if you're putting it up on an overhead or something. So I'm going to download this ping file. So it just downloads it as an image. All right, so then I'm going to close this. All right, then I'm going to come back over to Word, and I'm going to go ahead and paste it in. So what you want to do is insert the image into your file. Okay, so if you've saved the file as a file instead of as a screenshot, what you want to do is you're going to go over to Insert, and it would actually work for a screenshot to it, and it just depends on where you saved the screenshot. So we're going to come to Pictures, and we're going to insert a picture from File. All right, so this one's saved to my Downloads file, so I'm just going to click on it or double click on it and say Insert. All right, so this made a really nice big picture. So I'm going to click on the picture and I go to picture format and I want to make it smaller. So leave this checkbox checked so that the size stays the way it's supposed to be, and just decrease the size until it's the size you want. You can also type it in there. So I'm going to type in 3 inches. It's not letting me do that. Okay, I just paused the video for just a second and played with it. For some reason, it wasn't playing nicely with my screencast app, which sometimes that happens. And so I just grabbed a hold of the corners and did this. So you can do that too, which seemed to work better for me. Now I'm going to, while it's still chosen, I'm going to wrap the text square around it. So I'm just going to hit enter and get that back down underneath, and then I'm going to come back up here and I'm going to type the answer. Now I've got a picture just where I want it, and I can type off to the side of it, and I think that's going to look a little bit better. I'm going to get rid of this format box. Okay, so we want to answer the question, so I'm going to pause the video and do that so you don't have to watch me type. Okay, so I went ahead and answered the questions. The explanatory variable is temperature. That's the x-axis. The pattern, I think, is fairly linear. It's not perfect, but usually real data is not perfect. So it's sloping downward to the right, so it has a negative slope. There are, as far as I'm concerned, there's really no obvious outliers. Maybe this little point right here is a little bit of an outlier, but not very much. All right, so that's the first question. All right, based on your scatter plot, does it appear that higher sea temperature is correlated with less coral growth? So think about that one for a minute. As the temperature goes up, is the coral growing less? All right, so think about how you would answer that question. And I would say, I'm not going to type it here for you, but we'll just talk about it. I believe that, yes, that is the case. As temperature goes up, coral growth decreases. And you can tell that from the scatter plot, because as the points go to the right, the coral growth goes down. So however you want to put that in your own words would work. All right, the next question is, use Desmos to create the least squares regression line and paste your scatter plot with regression line below. Does the line appear to do a good job of summarizing the pattern of the points? Okay, I'm just going to assume that I typed in this section right here so I can get that down to the next page, and that way it's all together. Make a little space here for my graph. All right, let's go back to Desmos. And now we're going to make a regression line. And this is where it gets really fun. I'm going to add an item and I'm going to add an expression. So we're going to add a regression line equation. All right, so, and it's just where I wanted it to be. I wanted it to be above so that I can see both pretty easily. All right, so if you recall from Sal's videos, a regression line is the equation of a line, y equals mx plus b. All right, we are going to do that right now. I'm going to do y equals mx plus b, but we want to tell it to do a regression line, so we have to use a special symbol. So, and we also want to tell it to use this x1 and this y1. Okay, so we're going to type y1, and if you just type y and then the number 1, it'll do it for you. Now, instead of an equal sign, I'm going to do the tilde, the squiggly line that's at the top left of your keyboard. So y1 is regressed with m and then x1 plus b. And you may have seen right away before I even put the b in that it popped up with all these statistics here. Okay? So we've got a lot of information here, and I'm not going to worry about the residuals quite yet because that comes later. But for now, we just want to look at these statistics. We're looking at R, M, and B. Okay, so first we're just going to talk about M and B. So M is the constant that goes in right here in front of X, and B is the constant of the y-axis where it crosses the y-intercept of the y-axis. Okay, so is it true? You can take a look at it and see if that seems to be the case. I'll zoom out just a little bit. It looks like it's going to be crossing the y-axis, and I'd have to zoom out quite a bit to get it there, but it's going to cross the y-axis at 12.31. Okay, so now next we're supposed to copy and paste this into our Word file. So I'm going to share the graph again, and hopefully it puts the line on it. If it doesn't, I'm going to do a screenshot. So I'm going to export this image. Oh, look, there's the line. Excellent. So I'll download that file, and then I'm going to I'll close this, go back to Word, and right here I'm going to insert, again, just like I did before, a picture from File, and I've got another one, and that's that one. Yep, it's the later one, and I'm going to insert that. Okay, once again, it made it really big, so make sure this is checked right here so it retains the ratio of the width to the height, and I'm just going to shrink it until it's the size I want, and I'm going to come over here and say wrap text so that I can type around it. I'm just going to hit enter to get that back down. All right, so the question is, does a line appear to do a good job of summarizing the pattern of points in the scatter plot? So here's where you would just answer that question. Yes, it does appear to do a good job. I'm not going to type the whole thing, but do it in a full sentence, and I think that's all we're asked of in this question. Okay, I went ahead and answered the question, so you didn't have to watch me type. It does appear to do a good job of summarizing the pattern of points in the scatter plot. I added a question here. What is the R value, and how does it help you to know that it is a good job, is doing a good job of summarizing? So let's go back over here to our data. Now we have an R equals negative 0.8826. So I'm going to come back here and I'm going to say R equals negative 0.8826, which is close to negative 1. And then you want to explain what that means. So a positive 1 and a negative 1 is, both of those are a perfect line. Basically, it means everything fell on the line. The closer you are to 1 or negative 1, the closer you are to the correlation being pretty much perfect. So all the dots are really close together or right on the line. Okay, so negative just means it's got a negative slope, and positive means it has a positive slope. So this is really close. 0.8826 is a really, that means that the line, the regression line, is doing a very good job. That means the points are all really close to one another. So that's what you would want to say there in your own words. Okay, the next question asks us what the equation is for the least squares line. For this, we're going to need to go back to Desmos. I'm going to save this real quick so I don't lose it. So you want to look at the M and the B, and we're going to plug those in, and that would be our line. Y equals this number times X plus this number. Okay, so now what value should you round to? Because this is a lot of digits, so we're not going to deal with all those digits. The X goes to the tenths place, the Y goes to the hundredths place. We want to go to one more than our least number. So this one has 1, so we're going to go to the hundredths place. All right, so that means we're going to round M to negative 0.33 and B to 12.3. Okay, so we're going to go back and we're going to make a line, and I'm going to show you how to do that. So I'm just going to write it down real quick so I've got it. Y equals negative 0.33 X plus 12.3. So I just wrote that on a piece of paper. Sorry, 12.32 is what we're going to do. 12.32. Okay, 0.33 and 12.32. Okay, so now we're going to go back over here and we're going to insert an equation. So here we're going to insert, and the equation is here. Or with this, since we don't have any squared or anything, you could probably just write it without the equation editor. So we're going to say Y equals negative 0.33 X plus 12.32. Okay, so that is A. So they're asking us to do A, B, and C. So A was Y equals mx plus b. All right, and then B is the new equation with the temperature plugged in. So the question is, use the equation to predict the growth of coral when the temperature is 30 degrees Celsius. All right, so now remember, which is X and which is Y. X is the temperature, and they're giving us the temperature and asking us what the coral growth would be. So Y is going to be negative 0.33 times 30.0 plus 12.32. Okay, so I went ahead and put this in my calculator, and I discovered that when I cut these numbers off, I did not get a point on the line at all. I got a point way down here. So what that tells me is I think I want to use all of my numbers. So I'm going to come back up here and put in the whole 2, 5, 4, 5, 5. So I'm going to fix this while paused and then talk about it. Okay, so I just went and did this to make sure it fell on the line, and now it does. I put in the whole number, so that's what I would do in the future from now on, and in the homework that you do, is just use the entire number that Desmos gives you if for both M and for B, and plug in all your numbers, and then you can round the final number if you would like. So I wasn't doing what I taught you to do, was I? And it proved that it didn't work. So if you want to come up here and draw, I'm just going to use a point here of red. So I've got 30 degrees is going to be here, and if I come up, I will hit it right on the line. So the line helps us to predict where things would fall if certain things happened. So once we've tested a few points, the point of a regression line is then to say, well, this is the trend, this is the pattern, and if I had this situation, what would happen? So now we can make predictions. Okay, so to complete that problem, the last thing we need to do is just answer C. We have the answer here, we just need to round it to the correct number of decimal places. So now we're going to round. And if you look at this, the graph takes everything to the tenths place anyway, so we want to go one more place so that you can find a little bit more specificity between numbers there. So you would round it to 2.55 millimeters. 2.55 millimeters. Okay, so the next thing we're going to do is find the residual corresponding to the first data point, 3.2, 2.6. So you can either use the graph or you can do an equation. I like to start at least with the graph so that you can see what's happening here. So the first point is this 30.2, 2.6. That's the point that they're talking about. And they want to know the residual. So the residual is this distance right here. So we want to find this distance here. And there's two ways to do that. We can find the exact number using the equation, the exact number of this point right here. So I'm going to just scoot the mouse until I get the exact right number. So I was looking for 30.2 as my x value. And so the expected value here is 2.4883. 2.4883. Okay? So write that down somewhere, 2.4883. And we want to subtract that from 2.6 to find this distance right here, which is the residual. Okay, so I came back over to my worksheet here, and you would show this just by typing it, that's fine. So the residual here is going to be, so residual equals the y actual, so I'm just going to call that ACT, minus the y expected. That is the one that falls on the line, which is what we did when we looked here at Desmos. We looked at this y value here, and we are subtracting them. Okay, so we're going to subtract those, and I get 0.1117. All right, so that's the residual, that distance, that vertical distance that point is away from the line. Okay, so if you want to use the equation, you're just going to use the equation that we had before, which is was the y equals mx plus b. So y equals negative 0.325455. Hopefully I have these numbers right. If I don't, you can look up above and fix them. 55 times x, and the x is this value here, so you're going to put that in right here, 30.2, plus the b value that we found from Desmos, 12.317. Okay, so you're just going to put that in your calculator, and when you do, you would get 2.488259, which is also 2.4883. So you get the same number from the graph, or if you plug it in. And again, you would just take that number and you would put it in the same place you did there. Take y actual minus y expected, and that gives you the residual for that particular point. Okay, so the last two questions are about the residual plot in Desmos. So we're supposed to make residual plot and then again paste it here. Here's the cool thing. You just click plot and it finds each residual for you. So the one we found was, I believe, this one, and that is the number that we got, 0.1117. So we got the right answer. So you can double check the answer on the worksheet that I give you by doing the residuals. And if I just click this little zoom fit down here, it's going to show me everything on one graph. So now I've got the residuals right here. Okay, so what this shows me is for every point up here, how far away it is from the line. Okay, so the ones that are right at 0 means they are right on the line. So those points fit perfectly. And so what you want to see here is you want to see no pattern. If there's a pattern, it's kind of strange, but if there's a pattern, it means that the fit graph that we used, it wasn't a good one. So there are some that aren't going to follow a line. Instead, they're going to follow a parabola or some other shape. And so then you would say, no, a line does not describe this data. Okay, so, but in this case it does, because this is completely random. There's no pattern going on. Some are above, some are below. If there's like a V shape or some sort of Z shape or something, what it says is that the residual graph would then tell you that it's not a good fit. Okay, so one more time, we're going to export our graph. So export the image. Make sure everything's there. So the residual's there and the original line is there. So everything is showing. And I'm just going to download that and then go back to Word, and I'm going to do what we did before, and I'm going to go to insert a picture from file, and my most recent one is here. So once again, this is pretty darn big, and it went in the wrong place. So I'm going to undo that, and I'm going to try to go down here and tell it to do it again. So picture from file. So all I just did was hit undo. I'm going to try it one more time and see if I can get it in the right place. If I can't, I'm just going to drag it. Okay, yeah, I just had my cursor in the wrong place. Okay, so we're going to make that smaller. See if we can get it to fit. And I'm going to wrap the text so that I can, actually, there's no question, so I'm not even going to worry about that. Then I'm going to come down here and answer the question, which I already talked about, so you should be able to put that in your own words. So it is an adequate model for this data. All right, so I think that is it. Sorry for the long video, but hopefully that helps you learn how to do a number of different things using Desmos and Word to complete an assignment like this. So what you're going to want to do at this point is you're going to want to save your Word file with your name in it, or maybe your initials or something, and then just upload it to the assignment. All right, thanks for watching.